Welcome back to the deep dive. Ready for a topic that might sound a little intimidating?
Oh, really? Lay it on me.
Today we're tackling Olympiad-level geometry.
Okay, I see where you're going with the intimidating part, but hey, no pop quizzes here, right?
Exactly. We're talking about an AI that's basically a geometry gold medalist.
Now that's impressive. We're talking about the International Math Olympiad here, the IMO. That's like the Olympics for high school math whizzes. And those geometry problems, seriously tough. You need a deep understanding and creative thinking that's just, well,
Mind-blowing.
exactly.
So this AI, it's called AlphaGeometry2, and we're diving into the research paper from the folks at Google DeepMind, the AlphaGo
The
people.
ones who built the AI that beat a Go champion, yep, those folks.
Our mission today, figure out what makes AlphaGeometry2 so special and why anyone, even if they're not a math person, should care.
Okay, so buckle up. AlphaGeometry2 can solve a whopping 84% of IMO geometry problems from the past 25 years. That's better than the average score of a human IMO gold medalist.
Wait, 84%? Seriously? Okay, I'm officially impressed. But HLW, is it just some super-powered calculator?
Nope, it's way more than that. It combines a language model with a symbolic engine. Imagine you're solving a really tricky puzzle. The language model is like a super intuitive friend who suggests strategies, sees the patterns.
It's like, hey, what if we try this?
Exactly. And then the symbolic engine steps in. It's like a meticulous logician, checking if those strategies actually work, making sure it all makes sense mathematically.
So it's a real team effort.
You got it.
So has AlphaGeometry2 always been this good, or have there been some upgrades along the way?
Oh, there have definitely been upgrades. One of the biggest is they've expanded the language of AlphaGeometry2. It's like giving it a crash course in advanced geometry concepts.
Such as?
Well, they've added something called locus problems, for one.
Locus problems.
Well,
Sounds kind of sci-fi, to be honest.
think of it this way. Imagine a dog tied to a pole with a leash. The path that dog can trace as it moves around, that's its locus.
Okay, that makes sense.
AlphaGeometry2 can now handle these, plus problems involving linear equations related to angles and distances and all that, so it can understand even more of those crazy IMO problems.
So not only is it solving more problems, it's solving harder ones.
Yep, the kind that would make most people's heads spin.
Yeah, this is seriously impressive. What other tricks does it have?
Well, remember how we talked about the symbolic engine being super logical? Well, they've made it even smarter. AlphaGeometry2 can now handle something called double points.
Double points, like extra credit for tough problems.
Not quite. Sometimes you have points that seem different, but they have the same coordinates. AlphaGeometry2 can recognize these and use them to find creative solutions.
Like a shortcut, a trick that humans might miss.
You got it.
I'm starting to see the potential here. But how do you even teach an AI geometry? Are there tiny AI students with digital blackboards?
I love that image. No tiny blackboards, but
Yep.
they do create tons of what's called synthetic geometry data.
So not real IMO problems, but stuff made specifically to train the AI.
Exactly, and here's the cool part. They start with randomly generated diagrams, not problems humans made.
Oh, that's interesting. So the AI isn't biased by human approaches.
Right. It's learning from scratch, in a way.
So it's not just mimicking us. It's coming up with its own way of understanding geometry. Amazing.
Mhm.
So synthetic data, is that it? Or did they do more?
Oh, they definitely didn't stop there. They also created a new search algorithm called, get this, SECT. It stands for Shared Knowledge Ensemble of Search Trees.
Okay, that's a mouthful. What does it do?
Imagine multiple teams searching for buried treasure, each with their own map. These teams, or search trees, work at the same time, exploring different paths to the solution.
Okay, I'm following.
But they constantly share info about what they've found.
So it's a collaborative treasure hunt.
Yep. And they use different types of search trees, each with its own strengths, like a diverse team.
It's like a dream team of AI explorers.
Exactly. And they found that combining these different approaches through SKEST is the most effective. Kind of highlights the power of different perspectives, even for AI.
This is amazing. And to think it's happening in geometry, which some people might think is, well, a little dry.
That's what's so cool about it. It's not just about geometry, it's about AI tackling complex reasoning, something we used to think was uniquely human.
You definitely piqued my interest. Before we move on, though, let's talk about the language model itself. The data, the algorithms, that's all fascinating. But what about the brain of the operation? Any changes there?
Oh, absolutely. There have been some really interesting upgrades to the language model itself. AlphaGeometry2 now uses. AlphaGeometry2 now uses a language model based on Google's Gemini architecture. Think of it as a major brain upgrade.
A brain upgrade, huh? I'm listening. What's so special about Gemini?
Well, one of the coolest things is it's designed for multimodal learning. It can process info from different sources, not just text.
So, like images, too.
Exactly. In AlphaGeometry2, they're experimenting with adding visual info from diagrams along with the text descriptions.
That makes sense. Geometry is visual, right? Being able to actually see the problem must help.
Right. It's like the difference between reading a recipe and watching someone cook.
I get it. So this opens up some interesting possibilities.
Definitely. Imagine describing a problem in plain English, or even sketching it, and the AI solves it. AN creates the diagram. That's what they're working towards.
That would be incredible.
Yeah.
But for now, they're mainly using text, right? What kind of results are they seeing with this new language model?
Really impressive results. They've seen a big jump in performance on those IMO problems.
Nice. But walk me through how it works. So you can't just read the problem and spit out the answer, right?
Oh, definitely not. Remember the analysis string we talked about? That's key.
Right, the cheat sheet for the language model.
Exactly. It tells the language model what the symbolic engine has figured out. Helps it focus.
Okay, I'm with you. So they're working together. But how does the language model learn to make those auxiliary constructions in the first place?
It learns from all that synthetic geometry data, millions of problems and solutions. It sees the patterns, learns the strategies.
Like a student studying tons of examples.
Exactly. And just like a good student, it doesn't just learn one way. They've experimented with different training methods.
Like what?
They've tried training from scratch, fine-tuning, and multimodal training.
Okay, break those down for me.
Training from scratch is like starting with a clean slate, learning everything from the synthetic data.
The basics.
Yep. Fine-tuning uses language models that are already good at math and trains them specifically for geometry, like extra coaching.
And multimodal is using both text and images.
Exactly, learning from both sources.
So they're really trying everything, but which is best?
That's the interesting thing. There isn't one best approach. Different models, trained in different ways, often find different solutions to the same problem.
Huh. So different styles, but same goal. It's like a team of human mathematicians working together.
You got it. And that's how they're using these different language models. Remember Skest with those multiple search trees? Well, they're using different language models in each tree.
So it's like a team of AI geometers, each with their own style, working together.
You got it. And it's not just about finding any solution. It's about finding the most elegant, insightful one. The kind that makes a human mathematician go, wow, I wish I'd thought of that.
Okay, now I'm really interested. Can you give me an example?
Absolutely. There was a problem from the 2024 IMO. It involved proving a relationship between these two angles in a super complex figure. A lot of approaches would have used tons of calculations, lots of steps. But AlphaGeometry2, it found this amazingly elegant construction that simplified everything, led to a proof that was so straightforward, like finding a hidden shortcut.
So not just finding a solution, but finding the best solution, the most elegant one.
Exactly. That's what's so groundbreaking. It's not just copying how humans solve problems, it's pushing the boundaries. It's almost like it's teaching us new ways to think about geometry.
Okay, that's pretty mind-blowing. But let's zoom out for a sec. Why does all this matter? It's cool an AI can solve math problems, but why should anyone else care?
Because AlphaGeometry2 isn't just some math trick. It shows how far AI has come in understanding complex reasoning. And that kind of reasoning, it's important everywhere, not just in math.
So you're talking about applications beyond geometry.
Absolutely. They're already trying to expand AlphaGeometry2. Imagine a system that solves geometry problems just from you talking. No need to code it or anything. You just describe it, maybe even sketch it out, and the AI gets it.
Wow, that's powerful. What kind of impact could that have?
Think engineering, architecture, designing buildings, bridges, all that. This could change how we do it.
What about fields we don't usually connect with geometry? Medicine, maybe?
Yeah.
Social sciences?
Oh, definitely. Imagine AI analyzing medical images, helping doctors spot things we might miss. Or in social sciences, finding hidden patterns in data, helping us understand human behavior better.
So it's not about replacing us, it's about giving us better tools.
Exactly. AlphaGeometry2 isn't just about what AI can do, it's making us rethink our own creativity and how we solve problems.
It really makes you think, if AI can handle something as complex as Olympiad-level geometry, what else can it do?
It's such an exciting time for AI. What we talked about today is just the beginning. Who knows what's next?
I can't wait to see. We've covered a lot in this deep dive. How AlphaGeometry2 works, how it solves problems, and what it could mean for different fields. I'm walking away with a sense of awe and a bunch of new questions.
That's a good thing, right?
Definitely. And for everyone who wants to learn more, we'll have links to the research, the IMO website, all that good stuff in the show notes.
Check it out.
And as you explore, here's something to think about. If AI can master Olympiad-level geometry, what else can it achieve? The possibilities are really endless.
No doubt about it.
That's a perfect place to wrap up. Thanks for joining us on this incredible deep dive into AlphaGeometry 2. And until next time, keep exploring, keep learning, keep asking those big questions.